All right. I drew a line, and that line indicated that did we finish the log base 5 of 3x squared minus 3?
You just have to write it down.
Got it. Okay. All right. So this is where we were at. What are we going to do first? Do you remember the word? Condense. Very good. So we've got double logarithms here separated by a minus. We're going to condense them into a single log. And what will the argument of the condensed log be? Had a kid. Pause this real quick. All right. And this is not a log dropper, right? This is a water cycle problem. So let's knock it out. So we're going to hit it with, remember, we start with base to the log. So we're going to just put 25 equals. And then remember that when you finish the water cycle, the base to the log is always equivalent to the argument of the log. So that's going to equal 3x squared minus 3 over x plus 1. And at this point, it's no longer a question about logarithms for the next minute or two or three. It's just an old equation. Some of them are linear, some of them are rational, like, quadratic, whatever. What would we do to both sides here? Yeah, yeah. So we're going to multiply both sides by x plus 1. And the reasoning there is because we just want what I'm about to do in purple to happen. That's the goal, right? Whatever else happens, happens. But we did it for that reason. So now we're left with what's on the left over here. Nice. Mhm. You have to distribute, right? I think the parentheses that I put up out here in red are pretty important. Like if you didn't put them, I'd still probably know what you were doing, but putting them will help you remember to distribute, I think. And now you identify your opponents and say, oh, you're a quadratic. And then our training kicks in and we say quadratic, set it equal to 0. And so that's the next objective. And I'm going to focus on the right side because I don't want 3x squared to go bad. All right, we don't want him to move. So 3x squared and then what? Minus 25x always goes second. Remember, your terms need to be in standard form, right? We don't just put them wherever we want. And then what goes after that? And there we are. And we arrive at a problem now within a problem. And that is just, can I solve a quadratic equation? I don't know that any of these are going to require the quadratic formula, bless you. So I feel like we should just knock this out. The good news is with this, if we're going to test the factoring, is that the number in front, yeah, it's like not 1, but it's a prime. So it's not going to be that bad. So let's try out 3x and 1x, and then we do need to know our signs. What are they going to be? One of each. And we think of all the numbers in the world, whole numbers that multiply to make 28. Now I'm guessing the most instantaneous one that pops up is 4 times, right? So those are where I feel like I should go first. I don't know that they're going to work, but that's okay. We'll see what we can find. Um, Thoughts on this? I don't think it's working. I think if we put a 4 here and a 7 here, we get
Almost.
I know it made me think, I wonder if I have a typo somewhere, but let's have faith that everything's okay and that maybe the numbers are just a little bit more elusive. Obviously, it wouldn't work if we switched the 4 and the 7, because then we're going to get 7 minus 12, which that ain't happening. So I think we can throw 4 and 7 away. And let's head to another pair. What else multiplies to make 28? And I just saw it, but I don't know if you saw it or not, but this isn't going to work either. But oh, and I kind of put it in the wrong place, right? If this had any chance of working, we'd want to put the heavy 14 over here to create mass so that when it multiplies by the 3, we get that negative mass. But this won't work either because that's 2 minus 42. Did anyone spot it while I was up here clumsying around with my pen? What else multiplies to make 28? Does that work? Switch those signs. Yeah. So it kind of works. I consider it a success, but a kind of a little bit of a tempered success, right? So it does make 25, which is woohoo, but it doesn't make the right kind of 25 because these make 28 minus 3, and that's no bueno. So yeah, quick sign switch will do the job. So if we switch it from plus then minus to minus then plus, then we switch the power. The power dynamic changes. And what are our answers or our candidates, I should say? What do we get from the first guy? X equals 28 over 3, which in a moment we're going to really be smart if we think of it as 9 and 1/3, right? That's going to help us when we go to estimate whether or not it breaks any rules. What do we get from the second guy here? All right, so our candidates are written up here in yellow and red, and our job now is to go back and just see if they break any laws. All right, so let's go check. Let's start with the annoying one first, the 9.3 guy, 9 1/3. If we go back to the very beginning and put him in here, is 9 1/3 squared times 3 minus 3 going to be positive or negative? Super positive, right? Mega positive. So he's good. And if you put him over here, we good? So I think one of our answers being 28/3 can have a box. Passes, flying colors. And then I saved the easy one for last. It should be the easy one, and that is the candidate -1. So again, we return to the beginning, all the way to the beginning. Okay. And let's see if -1 poses any problems. In the first one, what is in this first yellow egg thing? What's -1 squared? 1. And what's 3 times 1? What's 3 minus 3? Is that going to be a problem? It is. Having just taken a quiz on evaluating logs, you know that logs cannot have an argument of 0. The -1 produces an undefined result. Therefore, he is out. Okay. Lots of mathematics to do in a problem like that. It's so many things combined into one. All right, let's go again. And I am going to listen. I thought of, I'm just going to throw a natural log at you. The natural logs that we talk about on Monday are going to matter. This natural log won't. And if you don't know what I mean, you will soon. Okay, so we're going to do the natural log of x plus 4 minus the natural log of x minus 2. We're going to set it equal to the natural log of x minus 6. Looking ahead, I know you're busy writing down the problem, but looking ahead, why don't the bases matter? Because we can drop them, right? So yes, the fact that they're all E is important. Like they all match, that's great. But the key is that there's a log on the right-hand side. And you really need to differentiate between, do I have a log equals a number, like a 5 or something, or do I have a log equals another log? Because as we learned yesterday, if we have a log equals a log, then we drop the logs and solve from there. So that's why I say natural log in this case is, it could have been log base 5, 15, 23, whatever, it doesn't matter. But we do need to condense first. So the rules are still rules. I have to take these and condense them into one. What is it? Natural log of what? Right. With that out of the way, this is the point in the problem at which we just eliminate the logs and solve whatever's left, right? Got it? Okay. So I am going to do what you would do, because you wouldn't want to erase it like that. So we're going to just copy down x plus 4 over x minus 2 and set it equal to x minus 6. And now we algebra. How do we get going on this? Yeah. And I know it's early, and a lot of times you guys just don't answer questions because it's early, but I do hope you understand that without fail, I'm going to say it again, monkey C fraction, monkey kill fraction. Like I'm telling you straight up, that has got to be your algebra bottom line. I see x over 5, I'm gonna multiply by 5. I see x over a little drawing of a puppy dog, I'm multiplying both sides by a little puppy dog. Like it doesn't matter C fraction, kill fraction, right? Okay, we want everybody up on the ground floor. So these x minus 2's, perfect, go bye-bye. And now we're left with x plus 4 equals what? That's the worst thing you could have said. In fact, I might send you to Mr. Townsend's office for that. You know how in the real world there are certain crimes that get you like automatic life sentences? I'm not going to say any of them because they're really bad, but in mathematics, especially from Algebra 2 on, I speak for everyone that does what I do for a living across this great land, probably in like Malaysia, Soviet Union, oh, wait, it was called Russia, right? It's not the Soviet Union. Uzbekistan, is that a place? Uzbekistan? Greenland? You know, the place that our president thinks we should invade and take over. You know what I'm talking about? Yeah, it doesn't matter. Any teacher would agree that if you say that this equals this, you should probably do somewhere in the neighborhood of 16,000 hours of community service. Okay, I'm done now. So would you like to try that again? You scared now, aren't you?
You can't try.
Ah, good point. He's already incarcerated. All right. Let's act like we're not a bunch of rookies, and let's remember that when you multiply two binomials like that, you have to do four multiplication problems. Here, let me remove some things from the board, and I'll color code it for you as if we were back in Algebra 1. Are you ready? I'm dropping some serious business on you here. Yeah, I remember the first time I did this too. Seriously, don't be too hard on yourself. Here goes. What's x times x? All right, good. That was a good answer. What's x times negative 2? What's x negative 6 times x? And what's negative 6 times negative 2? Yeah. And so that's where we get the answer, x squared minus 8x plus 12. Let's all make like a pinky promise that we'll just never do that again. Awesome. And then what pops out is a quadratic equation. And again, our training kicks in and we go, set it equal to 0, right? So I'm going to leave x squared right where he's at. He looks pretty happy there. So x squared, stay. How many x's are going right next to him? So again, -7 would be another probably 40 to life sentence in math
Yep.
prison. You'd be serving now consecutive sentences. You wouldn't get out probably ever. So you're just checking all the boxes today. Nice work. So when we subtract x from both sides, we get minus 9x. And I'm going to ask again, if you say 16, I'm never letting you back in my room again. What will go after the negative 9x? I can't threaten you with things because I'm recording right now, but just know that there's a lot of ideas churning around in my brain. All right, I got this. Yeah. That was some pretty rough algebra there. And now we're going to factor. So we're going to come up with x minus 1 and x minus 8. That's like super light work factoring. What are our candidates for answerism? Yes. So now we're going to take those numbers, very patiently go back to the very beginning of the problem, pre-condensing, and we're going to pop those numbers into any place we see an X and see if any laws get broken at all. Let's check 1 first and see if he's a little rebel rouser. If I put 1 here, we good? Sweet. If I put 1 here, we good? Nope. 1's out. Breaks a rule. Ka-chung. Gets hit with the super slash. Let's go check ocho. I believe 8 passes the first test. 8 passes the second test. 8 also passes the third test, which means 8 can have a box. So the solution to the equation is x equals 8. The other one would know. Good. One more. You excited? Let's go. Let's do this. It's going to be a, well, never mind. I'll let you see. Landon, you get a chance to redeem yourself, by the way, okay? You don't strike me as the kind of guy that would not seize every opportunity to redeem yourself for an egregious error. Your character that you've revealed over and over again tells me that you want a shot at redemption. You're not a quitter. Good news, I guess it's a log dropper. I don't know, but as you saw from the last problem, that doesn't necessarily make it like super easy or anything. It's just, anyways, let's condense. And I think that Mr. Thorup is going to have his moment in the sun here. So we're going to condense this into one single logarithm with a base of 9. And I'm just going to put a set of parentheses here and just await your glorious answer to what is x minus 7 times x minus 4. You've already got 2 life sentences. I mean, what you got nothing to lose.
I will throw it in.
How about this? I'll commute both sentences if you redeem yourself here.
Oh, boy.
No, you're not. No, I'm waiting on Ulysses S. haircut over here. I want to know what he has to say.
Nope, stress is getting to me.
What's the matter, Colonel Sanders? Chicken? Do I have time to go like run an errand while you calculate
Yeah,
this?
because I'm stressed, man. Oh, getting there.
What is it that SpongeBob always says? Like 20 minutes later. Is that a thing in SpongeBob?
I can kind of wait on me.
Because you need to redeem
You're
yourself.
not redeeming anything because I'm gonna do worse.
You can't do worse than what you did last time.
Oh, I'm struggling. I'm good. Yeah, seriously, because I'm lost.
Fergie, you were going to go. I'm ready.
No.
Thank you, ladies and gentlemen. I'll show myself out. Life sentence, no parole.
Mine is 28.
Well, that makes it better. Sure. Let's just change the rules of math and make a negative times a negative just for, what the heck. That's funny. I was just talking to my wife last night about this. I've had a rough couple days, and I was telling her how high school and junior high students are hilarious because I'll say something like, what's -4 minus 15? And I know the answer is -19. But let's say a kid messes up by a little bit and they say like -18, and I just stare at them. Then they say something ridiculous like, oh, a +19. And then the fireball just grows. Yeah, I just really need to act like none of this happened here today. Jackson, I'm a little scared, but I'm ready.
Anything can happen with me, so it's either right or horribly wrong. X squared minus 11x plus 2.
Yeah, I mean, like, do we as a class need to go back and do a whole worksheet on multiplying binomials? You guys are freaking me about through the floor right now. Ooh. What a good teacher does is he or she recognizes deficiencies in his or her students and then acts accordingly. So perhaps this weekend I need to assign an extra worksheet of just multiplying binomials. Does that sound like a plan? x squared plus 28.
I forgot about the,
Uh,
one. Sorry.
So now we've made it this far, and it's time to drop a deuce, right? We're going to drop some logs. So we're going to have x squared minus 11x plus 28 equals x plus 1. And somehow, through the grace of God, we've made it this far, and we've arrived now at our, I don't know, kind of intermediary destination. We got us a good old-fashioned quadratic here. How are we going to solve them? X squared and then what?
it's 12x.
Yeah, so I had just told myself if any one of them says minus 10x, I am literally calling the office and going home. So thank you for saying that. And then after that is plus 27, rad. And this one ought to be pretty quick and easy because it's pretty, assuming you know the basics of factoring, that it's a pair of minuses, of course. And then you know your times tables, and you know 3 times 9 is the most common factor pair. You're like, hey, how nice, 3 and 9 also add to make 12. Woo! So our answers are candidates are x equals 3 and x equals 9. So we have to go back now and check. Any laws get broken by these little rascals? Let's go check. Let's start with 3. 3 busts up right away. Boom. 3 minus 7 is negative. So you can go ahead and give 3 kachunka. Hit him with the slash. Please don't scribble things out because I got to still read what you have. So a nice slash lets me still see it was there, but it also tells me you acknowledge that it's no good. Let's go check 9. How's 9 looking? Good, good, good. 3 goods. Orange whip, 3 orange whips. Yeah, that's it. There's so many more examples that we have yet to go, but those are Monday examples. I am done now. Your job for the next 25 minutes is to try to finish all the problems on there except the circled ones. If you do not accomplish that task, then just look on the bright side. You've got, hold on, let me count on my fingers. 95 hours and like 30 minutes to finish the other ones before Monday. That's a long time. So my expectation is that when I see you here bright-eyed and bushy-tailed Monday morning, that you'll be ready to say, I'm done with all of these and I'm ready to move on to the other notes. Got it? I'm leaving this recording going because I have a sneaking sense you might have some questions.